Using functions to solve a problem is something that we can kind of go through to find values that are maybe way off from our graph, or they would be, if we were to make, let's say, a t-chart and find a pattern, these would be ones that are way down that t-chart, and we don't really want to make a million different numbers on the t-chart or 100 different numbers on the t-chart to come up with our answer. And so we make a formula or an equation which helps us to solve those problems. Once an equation has been made for a linear function, then any point on the line can be found. Okay, so if we figure out what the pattern is or what that equation is going to be, then we can find any single value later on down the road or even prior. Okay, so if we have a bunch of late numbers, we can find the prior numbers, maybe when it equals 0 or something along those lines. Each point, okay, is again represented by an x value, which is our independent variable, and a y value, which is our dependent variable. And these form our coordinate point x, y, which is some point that is on our line. Okay, at some point that's on our line, it's somewhere along this line, or maybe off the screen or below the screen, or whatever the case is. So how do we do this? Okay, first things first, we need to figure out what that equation is for the graph. Okay, so let's use the given graph to solve these problems. And what I'm going to do is, again, quickly label this here, 2, 4, 6, 2, 4, 6. We're going to assume, at least I'm going to assume, that when I was making this, it was supposed to be going up by ones. Again, very important that we have our everything set up there. We have all our numbers so that we know, or the person reading the answers knows which values we're using. So let's write the equation of our linear function. Y equals mx plus b. Y-intercept right there, 0, -2. Here's another point, 2, 1. Okay, we have a slope of 3 over 2. 3 over 2x. We have a y-intercept of -2 minus 2. There we go. It's that straightforward to come up with an equation because we know our y-intercept and we know our slope between those 2 points. Okay, we could use this point here as well, or we could use this point there as well. Those are nice points. And that would be a rise of 3, run of 2, rise of 3, run of 2, rise of 3, run of 2. Or a rise of, this would be 9, run of 6, which simplifies to 3 over 2. So the slope will always be the same. Let's verify the line using our y-intercept. So if we are to plug this in, okay, our y-intercept, when x is 0, y should be -2. So we do y is equal to 3 over 2x minus 2. We're going to put 0 in for x times 0 minus 2. 3 over 2 times 0 is 0 minus 2. Y equals -2. Boom, it works. That is a verification of that equation, of that line. Okay, so that's how we go through and verify. We take an x value, we solve for the y value, and it should be one of them on the line. We could do that with any of them. I'm going to do one more example here. Okay, this point right here is 4, 4. Let's see if that works. Let's put 4 in there, -2. This one's a little tougher to do in my head, so I'll do it with a calculator. 3 over 2 times 4 minus 2. Whoops. Minus 2 gives me 4. Perfect. 4, 4. That's one of the points. X is 4, Y is 4. That is a point that's on the line, or at least a point that we are saying is on the line. Now, let's continue this. So when x is 100, so let's continue this line out to be 100. Okay, now I'm assuming, and again, if we were doing this in class here, I would be kind of explaining that it would be somewhere way outside of class, because this is 6. 100 is going to be way out that way, and this line is going to keep on going way up that way, and so we can't really graph this to come up with that point. So let's figure out when x is 100, what is the y value? Well, y equals 3 over 2x minus 2. Y equals 3 over 2. Let's put 100 in there for x, and let's subtract 2. And let's use a calculator again, because without a calculator, that just becomes a bit of a hassle. 3 over 2 times 100 minus 2 is 148. So the point is 100, 148. When x is 100, y is going to be 148. And that's based on the equation that we came up with. So we would have to extend this out to 100 and this up to 148 so we could actually find where that line goes through that point. What about the other way? What if y is 100? Okay, so y 100, we won't have to go quite as far up or quite as far this way, would be my guess. Y equals 3 over 2x minus 2. We're going to put 100 in for y, 3 over 2x minus 2. We want to get x all by itself. This is going to be a little bit more difficult, and I'm going to show you a couple different ways that we do that. First things first, this is the easy part. We add 2 to both sides is equal to 3 over 2x. Now 3 over 2 is just a fraction. It's 1.5. Okay, so if you want to change it into decimal, 3 divided by 2 is 1.5. Or we can just divide by the fraction. So 102 divided by 3 over 2, if your calculators have that. And I got that x is equal to 68. Okay, so we would have the point 68, 100. There we go. Y is 100, x is 68. The other way, okay, is to divide by 1.5. We would do 1.1 over 2 divided by 1.5, get exactly the same answer. Our last way, it is a fraction, so it's multiplying by 3 and dividing by 2. So let's do the opposite. So let's do 102, let's multiply by 2, and let's divide by 3. Same answer. So there's a couple different ways that we can go through that and come up with our answer for x. And that gives us that point. So that point would be over here. We go over 68 and we go up 100, and that would be our point way up there somewhere off the screen and away from your Chromebooks. Now, if that was to be in your house, it would be through the roof probably, or unless you have a multi-storied location, maybe it would be up on another floor, 2 or 3 floors higher, depending on how big your screen is right now. So that's just a way of coming up with points, and this is what we call extending our graph or extrapolating to find the information. Now, the last little bit that we're going to do here at the end, when we say verifying, so verifying the equation using points that can be seen on the graph is helpful to confirm that the equation that we've created is in fact correct. Okay, we hope it's correct and we try to make sure it's correct, but sometimes we may have made a mistake. If we confirm with a couple of points like we did here, okay, I confirmed with y-intercept, I confirmed with 4.44, and if both of them work, that probably means that we made the correct line. We could, if only one works, then we may have made a mistake somewhere else with either slope or y-intercept, but if both of them work, that means that we probably did both of those parts correctly.